you open a website, send an email, or upload a file, it feels instant, almost effortless. But behind that simplicity, there's a well designed system working continuously to make communication possible. At the center of that experience is the application layer, the top layer of the TCP IP model and the one closest to you as a user. To truly understand networking, it's important to begin here because this is where human interaction meets the network. The application layer is responsible for providing network services directly to the applications we use every day, like web browsers, emails, clients, file transfer tools, and many more. However, it's important to be clear about one thing. The application layer is not the application itself. When you open a browser like Chrome or send a message through an email app, those are applications. But the moment these applications need to communicate over the internet, they rely on the application layer to make that communication possible. In a way, the application layer acts as a bridge connecting the user intent with the network communication. Without this layer, every application would need to handle networking on its own. That would mean no standard way of communication, no consistency, and a much more complicated system overall. Instead, the application layer simplifies everything by providing a structured and standardized way for application to interact with the network. You can think of it as a translator, something that takes human-friendly requests and prepares them in a form that the network can understand and process. If we look at how we use the internet in our daily lives, we will realize that almost everything depends on this layer. Browsing websites, sending emails, transferring files, accessing the remote systems. These are not separate systems working independently. They are all services provided through the application layer. Even something as simple as typing a domain name into a browser involves this layer. Because before any communication can happen, that domain name needs to be resolved into an IP address. This is where protocols come into picture. Protocols are essentially a set of rules that define how communication takes place. They ensure that devices understand each other and exchange data in a predictable and reliable way. For an example, when you load a website, communication happens through HTTP or HTTPS. When a domain name is converted into an IP address, DNS is involved. When files are transferred, FTP is used. When emails are sent, SMTP plays a role. And when secure remote access is required, SSH is used. Each of these protocols has a specific responsibility, but together they create a complete communication system at the application layer. To make this more intuitive, think about what happens when you open a website. You enter a domain name and almost instantly, the correct web page appears on your screen. What actually happening in the background is a coordinated process. Your request is prepared, sent to the appropriate server, processed there, and then a response is returned back to you. All of this happens seamlessly, and it is made possible because the application layer manages how this interaction is structured. It ensures that your request is understood, delivered, and responded to the user correctly. Another important perspective comes when we compare this with the OSI model. In the OSI model, the responsibilities we are discussing are divided into three separate layers: application layer, presentation layer, and the session layer. But in the TCP IP model, all of these responsibilities are combined into a single layer, the application layer. This means that in the application layer in TCP IP, it is not just responsible for communication, but also handle aspects like data formatting and session management, which are separated in the OSI model. Security is also an important part of this layer. Not all communication is inherently secure. For instance, HTTP transport data in the plain text, which means it can potentially be intercepted. On the other hand, HTTPS adds a layer of encryption, ensuring that the data being transmitted remains private and secure. When we are bringing everything together, the application layer can be understood as the interface between the user and the network. It is the layer that allows application to communicate effectively, provides essential services like web access and email, and relies on well-defined protocols to ensure everything works smoothly. In the next video, we will go one step deeper and explore what actually happens behind the scene when you open a website, from the moment you type a domain name to the moment the page loads. And that's where the real flow of networking begins to make the complete sense. If you like the video, don't forget to like, share, and subscribe for the Government Tech for more content. Thank you so much for watching.